Hello everyone, today we are going to continue our lecture on atomic theories and we are going to proceed from advancement to the Bohr's atomic model. So we have covered up to the Bohr's atomic model and we are going to see the advancements done on the Bohr's atomic model and we try to find out that which of the models would properly capture the truth behind the fine structures. Okay, so let's go ahead. So before going to any other models, let's first revise what the limitations of Bohr's model were. First, first was that he didn't had any explanation for fine structures, although he did talked about spectral lines in the hydrogen spectra. Okay. Similarly, another another limitation was that he integrated the quantum as well as the classical ideas, but he didn't had a proper explanation for why that would work in the physical reality. Another limitation was that it was only applicable. The Bohr's model was only applicable for one electron atomic systems. That means if we try to use Bohr's atomic model, that is the circular model, into multi-electron atomic systems, that would fail. Okay, so these were some of the limitations of Bohr's atomic model. So after Bohr, Sommerfeld came into the picture, and he thought that the fine structure lines may be explained if we had different energy levels for the same energy band. And for that, he suggested that if we could divide, or if we could divide the principal quantum numbers into some other quantum numbers, then if we had those two, three, or a number of quantum numbers, then we could capture the reality behind the fine structures by assuming the spectral line or the spectra that comes from different cells of the same energy band. Okay, that was his thought. Let's talk about Sommerfeld postulate. He came up with two postulates. First one suggested that electron might revolve not in the circular orbit as suggested by Bohr, but rather in the elliptical ones. Okay, and the other postulate was that the velocity of electron, if it revolves around the elliptical orbit, won't be same at all the points of the orbit. That means if the nucleus and electron are nearer to each other, then that would suggest there would be different speed than that in the case when the electron and nucleus are far from each other. Okay, so that means the electron would experience a relativistic variation in mass when it moves around the elliptical orbit. So that means we have to have relativistic equations. So that were the two postulates of Sommerfeld. Now these are the derivation part, which suggests that if we could break down the principal quantum number, which is n, into, I am very sorry for my handwriting, I couldn't uh, write better than that using keyboard, sorry, not keyboard but touchpad. So he assumed, just please bear with me, okay, don't mind this one. So the principal quantum number can be divided into two quantum numbers. First one is azimuthal quantum number that hold account for this azimuthal angle if we consider an elliptical path for the electron. Similarly, this one is the radial component or the quantum number, which suggest or which hold account for the radial distance at each point between the nucleus and the electron. So he suggested that if we divide these principal quantum numbers into these two components and we do some calculations, actually very lengthy calculations, then we would arrive to the elliptical equations and we would get some special cases. First one, can you see it? Let me zoom it again. Okay. Yeah. So the special case that he mentioned where when both of the quantum numbers have, sorry, not both of the quantum numbers, but when azimuthal quantum number is equal to the principal quantum number, that means the radial component is 0, radial quantum number is 0. In that case, the orbit becomes circular. That means the circular orbits that Bohr suggested were just the special cases of elliptic orbit. Okay, that means that he thought at that contemporary time that his model is actually just the extrapolation, if you may, of the Bohr's model. Okay, so other special cases where if we consider the azimuthal quantum number to be zero, then that means the ellipse would degenerate into a straight line, and that means the electron. So let's suppose we have a straight line, and let's suppose somewhere here we have a nucleus. Then, if we consider an electron moving in this direction, then what would it do is that it would revolve around it, not revolve but just travel around it. That means the electron would go or pass through the nucleus twice to complete one rotation, and somehow it is not possible. Okay, and that means this case was neglected. Similarly, when n phi is greater than n, that means n phi is considered to be greater than principal quantum numbers, then that means it would be a hyperbola, right? And then hyperbola means this kind of scenario where we have a nucleus here and electron would travel from here in this hyperbola, but it won't come, it would pass once near the nucleus, then it won't come because the hyperbola extends to infinity. Okay, that means this kind of model or this kind of case is also not possible. The only possible idea is that when n phi equals n, it becomes the case that the orbits are circular, sorry for that, circular, and when n is equals to n phi plus nr, then the orbits will be elliptical. So these are the special cases, and we had to discuss them. Okay, yeah. Now let's talk about the energy of a single electron in an orbit according to Sommerfeld's model. So we already know that whenever an electron is revolving around a nucleus, then it would have its kinetic energy as well as due to the interaction or electrostatic sorry, not electrostatic in this case, but if we consider electron to be in rest for a instant of time, then that would cause a electrostatic interaction attraction, electrostatic force in between them, which will give the electron some potential energy. So we also have to keep that into account. So we can say that the energy, total energy of an electron of a single electron in an nth orbit would be kinetic energy plus potential energy. Now we know that if we had only one component or only one quantum number, that is n, then our kinetic energy would be uh, half m times v. Okay, now v is dr by dt, where dr means the change in distance. But here we also have a azimuthal quantum number, so we also have to account for that. So that's why we also have to add another component, that is r d phi by dt. Now this r here comes from the polar coordinates, and if you have heard about the spherical coordinates, then you would not be surprised that r comes there. Okay, now similarly we are already familiar with this term, which is potential energy, and this can be given as q1 q2 by 4 pi epsilon naught r, which is the potential, electrostatic potential. So dr by dt is the radial component of velocity, r d phi by dt is the transverse component of velocity. And if we substitute those terms into the this first expression, we would get something like this. And if we calculate further, we would reach to this point where we would get this expression. And this expression turns out to be exactly same as that of is that to what Bohr suggested. That means not only the elliptical cases were just the extrapolation of circular orbits, but the energies that the electron would have either in the case when they are revolving around the nucleus in circular orbit or the elliptical orbit, they would have the same energy. That means even though now that means that even though even if, let's suppose these both models are wrong, which they are, but let's suppose they are wrong, then one thing that is not wrong is that they are intrinsically doing something right, for which, even though no matter what the model they choose, they always are ending up to the same energy. Okay, now, it can be also thought of as the very obvious thing, because Frank Hertz's experiment has already told us that no matter what the model is, the atom would always have a definite energy at each energy definite energy at definite uh, number of cell, or what, how do I say it, the definite number of n. Okay, so and the energy would increase or decrease as the integral multiple of n. Okay, that was already suggested by Frank Hertz's experiment. So it is not so uh, very weird thing that we get the same answer, same energy, same expression for energy. Okay, now this is a very interesting part of Sommerfeld's model, the relativistic correction. Now, if you remember, we had discussed that Sommerfeld introduced the relativistic concept, and he justified that by saying whenever we have electron in elliptical orbit, that means the electron is revolving around nucleus nearly in the speed of light. And since the distance from the nucleus in elliptical orbit won't be same for electron at every single point of the orbit, That means it would have some relativistic mass errors or mass reductions, and that is what the relativistic concept of Sommerfeld elliptical model was. Now let's see what result would it give us. So, as we know from the special relativity that whenever we have a mass revolving nearly in the speed of light, then the mass reduction or the variation in mass is captured by this formula, which is, I suppose, it's a Lorentz factor. Okay. Now he found out that the velocity of electron in the innermost orbit is 1 by 137 times the speed of light, which is sufficient enough to include the relativistic errors, relativistic corrections, and the velocity of the electron in the elliptical path varies considerably, speeding up when the electron is near the nucleus and slowing down when it is far away. Sommerfeld took account to the relativistic mass of the electron. Sommerfeld, in his treatment of the elliptical orbit, had shown that the path of the electron was not simply an ellipse, but an ellipse with which precesses. That means the major axis of the ellipse slowly turns about the focus in the plane of ellipse, and the path of electron would form uh, rosette orbits. So yes, so here it captures the sense of precision. Okay, precision means if you had seen uh, okay, okay, let's not go there, but precision means whenever we have a spinning object, and whenever, if you see the spinning object in physical reality, let's suppose this is spinning, my cursor is spinning, then it would precess, or after some time it won't, if it has some definite speed, then after some time we won't see that it is spinning, but rather we just see it is just wobbling around. Okay, it's just wobbling around, and that spin is not quite visible, and at that kind of motion, the wobbling of the spinning particle is called precession. Okay, and this is what it says, that electron, not so electron precesses. Okay, and it would form a relative Rosette effect, Rosette orbits. This is what it says. Okay, now for the Rosette orbit, the equation for the path of the electron is taken as L by R equals 1 plus epsilon cos psi phi. Now the these are some very hard calculations, and after some times we would get this equation, which is the energy expression for the electron, including the relativistic correction. Okay, yes. So this is the expression that we would get. Okay. Now, one of the very interesting case that we get here is that we get alpha, and alpha has a value of 1 by 137, and it is called the fine structure constant. Okay, it's called the fine structure constant. And up to now, the reason behind the existence of fine structure constant is unknown. Scientists couldn't figure out that why this number works and why universe suggests this number for relativistic electron orbits. Okay, now let's talk about how did Sommerfeld explain fine structures through his model. So he postulated that in each board's orbit, there must be some suborbits or subcells that these electrons may reside in different energies, even in the same energy band. Okay, and this fact manifests as the fine structure creating splitting of a single spectra into multiple spectra of slightly different frequencies, even in the same energy region. Okay, this is what the Sommerfeld's explanation was. Now it turns out, though even though the Sommerfeld's math was perfectly correct, and whenever after some times when Dirac found out the relativistic expression of or equations of motion of electron around the nucleus, it perfectly matched with the Sommerfeld model. But since we haven't talked about spin, but since Sommerfeld haven't included the spin quantum number or spin of the electron, the physical explanation of Sommerfeld for the finite structure was totally gibberish. Okay, just it was not something that we would appreciate in the physical reality. Okay, now let's see the limitations of Sommerfeld model. The spectra of atoms having more than one valence electron could not be accounted by the Bohr and Sommerfeld. Even though Sommerfeld did some hard job explaining the elliptical orbits, but he couldn't really capture the truth behind what really happens in the spectra or fine structures. Okay, and another limitation of Sommerfeld model is that he couldn't predict the correct number of fine structures. Similarly, the third limitation was it couldn't give us the bigger picture of how electrons were distributed near the or around the nucleus. Okay, so it said that the electron could be in the circular orbit when we have particular case, or it could have elliptical orbit as you suggested, but it couldn't fully give a description of how electron will distribute it. Okay, it couldn't give us a proper atomic theory. So these were some of the limitations. Now here comes the ultimate truth behind fine structures as well as the atomic theory.